Hi, and our last topic from the this booklet is going to be SOHCAHTOA. So before we've done quite a lot, but we were looking at Pythagoras at one point, which was finding lengths inside a right angle triangle. Now that was fine when we knew two of the other lengths. We are now going to use trig, or right angle trigonometry, to work out lengths when we know an angle as well as a length. So the first thing to try and remember here is SOHCAHTOA. That's because sine of an angle is equal to the opposite over hypotenuse. Cos of an angle is equal to the adjacent over the hypotenuse. And tan of an angle is equal to the opposite over the adjacent. SOHCAHTOA. Quite easy to remember, actually. So if we look at our first triangle, we know this angle and we know two lengths. And everything is related to the angle that you're looking at. So I know this angle. What is the opposite? What is the adjacent? And what is the hypotenuse of the angle? So we're trying to work out each of these, which line corresponds to these. So 24, this is opposite the angle. This is adjacent to the angle. And from Pythagoras, we'll remember that is the hypotenuse, because that's opposite the right angle. So if I know this angle, this length is opposite the angle, this length is adjacent to the angle, and this is the hypotenuse because it's the one that's left, and it's also opposite the right angle. So what do I know? Well, I'm trying to find the opposite, and I know the hypotenuse. So if I write out my SOHCAHTOA, say SOHCAHTOA, and I'm looking for my O and my H. Oh, so it's going to be this row here. So I know I'm going to use sine because I know the O and the H. Well, I'm trying to find the O, but those two variables are in the question. So I'll go over to the side of the page just now. So I can say that sine of x is equal to the opposite over the hypotenuse. So sine of 24 is equal to x over 17, because the opposite is x and the hypotenuse is 17. Now to rearrange slightly. I want x on its own, and right now it's being divided by 17. So to do the opposite of divide by 17, I have to multiply by 17. And that gives me x. And that's it. We can now use our calculator, which does most of the heavy lifting on this. We're not having to do it from first principles or anything. Sine of 24, so that's going to give me 6.9. So x is equal to 6.9 centimeters. I'll just put that to get a bit of space on the board. So that's question 1 done. Let's look at question 2. Do the same again. So first time we want to label up our triangle. There's our angle, and we know something that's opposite the angle, and we know something that's adjacent to the angle. We do not know the hypotenuse. So I know an opposite, and I know an adjacent. So that's going to be TOA, because I know the opposite and the adjacent. Yeah, I can't do cos because I don't have the hypotenuse. I can't do sine because I don't have the hypotenuse. So it's going to be tan. So I can then say tan of x is equal to opposite over adjacent. That's TOA. And then I start filling in. I'll say tan of x is equal to 4.4 divided by 12.6. So tan of x is equal to, I'll just put this in, 4.4 divided by 12.6. So it's 0.35. Now at this point, we're thinking, right, I want to know x though. So how do I get x? How do I get rid of tan? What's the opposite of tan? It's not pale. That's not bad on the calculator. We want to do shift tan on our calculator, or tan to the -1. So to get x on its own, we do the inverse of tan on both sides. So it's tan of the -1, 0.35. So on your calculator, so we press shift tan 0.35. and that gives me x is equal to 19.3 degrees. So the opposite of sine, cos, or tan on your calculator is just shift cos or tan. But in mathematical parlance, you would say it's the inverse of tan to both sides. Because tan inverse tan, the tans cancel out, and I'm left with inverse of tan on this side. So that's a slightly trickier example. This one's an easier one because we just do sine over number and it's a very easy to rearrange. But this one we have to do the inverse to work out the angle. So if your angle's unknown, you'll be doing the inverse. Let's practice a few more then, shall we? So I know this angle here. I need to label up a triangle. That's the angle I'm working with, so that's opposite the angle, that's adjacent to the angle, and that's the hypotenuse. So I know an opposite, well, I'm trying to find an opposite, and I know the adjacent. So it's again going to be a tan, isn't it? So tan of x is equal to OR, opposite over adjacent. So tan of 48 is equal to the opposite, which is x, divided by the adjacent of 56. I now need to rearrange to make x the subject, so I'm going to multiply both sides by 56. And then I can just do that in my calculator. So because I'm not finding the angle, I don't have to do the shift tan. So 56 times tan of 48, and that tells me 62.2 degrees. Pretty straightforward. So we'll label our triangle, get our equation, substitute and rearrange. Straightforward. Okay, here's our angle. There's our adjacent. There's our opposite. And there's our hypotenuse, opposite the right angle. So in this case, I know the H and I know the A. So, it's not so because I know the O. It's K, isn't it? Because I know the H and I know the A. And when I say I know, it doesn't matter if I have the numbers for them. If I'm trying to find H or A, it's still cos. The point is we're using A and H. And just to double check, it wouldn't be tan, because again, I don't know the O. So it's going to be cos in this case. So I'm going to say cos of x is equal to opposite over hypotenuse, and then I start subbing in. Cos of x is equal to, adjacent over hypotenuse. Whoops. Can't. 118 divided by 142. And just like before, how do I get x on its own? Well, I need to do shift cos, which is the same as cos negative 1, 118 over 142. So don't stress out about the inverse of cos or anything. And the thing people might do is want to divide by cos, which you can't really do. Right, so we want to say shift cos, and it's 118 divided by 142, and that's going to give me 33.8 degrees. So that's us worked our way around all the different trig families: sine, cos, and tan, sol, ca, tor. All you have to do is label up your triangle, substitute in. So label up your triangle, identify your equation, substitute in, and then a slight bit of rearranging. And I'd say the only hard bit of rearranging is to remember to get rid of your sine, cos, or tan, it's shift cos. So we move it to the other side by saying shift cos. Good stuff. There's some more complicated examples here. I might just do one of them. And then I think that's us finished. Yeah, I'll do this last question and then that's us finished the booklet. So let's look at this. A new regulation states the gradient of all ramps in a building must be less than 0.26. Draw this ramp. Does this ramp satisfy the new regulation? Show your working. Okay, so the gradient has to be 0.26. Gradient is simply just the height divided by the length. And so there's our triangle. It's told us everything that's in this. So I suppose what it's saying is you can actually use Pythagoras for this as well. You know what, I don't like this question. You can use Pythagoras as well. I'd rather there's one with an actual angle in there. Yeah, you know what? I'll do one of these questions on the next video. But that's the end of our basic sports soul catalog. Okay.